Good day, students. So let's start with our first exercise, exercise 1.1. If we start with the first question, what we have is use Euclid's division algorithm to find the HCF of. First one is 135 and 225. So here the solution starts. Finding HCF of 225, 135 by division lemma we get. Now see here what we will do. 225, we will apply division lemma on 225 and 135. So what do we get over here? If I apply this 225, I'll divide by 135. Definitely it will not even go by 2. 2 5s are 10, 2 3s are 6, 2 1s are 2. It's crossing. So we get what? 135 1s are. This will become 0 and this will become 90. That's all. So this is your quotient. This is your remainder. So what we get? 225 is equal to 135 into 1. 135 into 1 plus the remainder is 90. Fine. Now the remainder has not become 0. So we have to now proceed to the next step, where now 90 will become the divisor, 135 will become the dividend. So 135 is equal to 90 multiplied by what? Again we have to divide this. 135, 90. So again if you will see, this is 2 9s are 18, 180. So again it will give 1s are only 90, 5, 9, 10, 11, 12, 13, 45. This is going to be your remainder. So you get 90 into 1 plus remainder is 45. Again now if you see, still the remainder is not 0. So again now 90 will become your dividend and 45 will become your divisor. And now it's clearly seen, 45 into 2 will give you 90, and that's all, plus 0. So here, since remainder is 0 when divisor is what? 45. Therefore HCF of 135 225 is equal to 45. This is your answer. Fine. So here we get along with the first question. Second one they're telling is 196 and 38220. 196 and 38220. Okay, fine. So again we'll do the same thing. Solution finding HCF of 196,38220 by division lemma. Of course, then 38220, this will, because this is a bigger number, this will become the dividend, and then I'll divide this by 196. So what do I get over here? So 38220, I divide this by 196. So here if you'll see 2 6 are 12, 2 9s are 18, 19, 2 1s are 2, 398. It is crossing, so this will go by 196. This will become 6, 10, 11, 12, 13, 14, 15, 16, 17. This will become 8, 3 minus 1, 2. This 2 comes down, so you get what? 2862. Just a minute, here 3. This will be 1. Yeah, this is borrowed from me. 1862. So then now if you go along, I will like to go to 2, 3, 4, 5, 6 are 30, 5 9s are 5 6 are 30, 5 9s are 45, 46, 47, 48, 5 5 6 7 8 980. It's still very low. 6 7 8 9, 6 are 54, 9 9s are 81, 82, 83, 84, 85, 86, 9 10 11 12 13 14 15 16 17, 1 7 6 4. This is okay. Now 9s I take 196, 9s are 1 7 6 4. This will become 12 minus 4, 8 9. This is gone. Now this 0 comes down. Now this will be divisible by 985. Okay, fine. 5 980. This is your remainder is here itself. Your remainder is gone. So what we get over here is 38220. Dividend is equal to, this is the divisor, 196 multiplied by 195 plus remainder is 0. So here your remainder is 0, since remainder is 0 when divisor is 196. Therefore HCF of 196,38220 is what? 196. That's all. Fine. Okay. Now we can go for the third question. 867 and 255. Fine. So 867 and 255. We will do the same thing over here. Here, solution. Okay. Now finding HCF of 867 255 by division lemma. So here of course 867 will be my first dividend. Hopefully now you understand what's happening, and my divisor will be 255 into what? So we will have to divide this again. 867 divided by 255. 867 255. So this will be going where 3 5s are 15, 3 5s are 15, 16, 3 2 6 7. I hope this is there. 4 5s are 20, 4 5s are 20, 21, 22, 4 2s are 8, 9, 10. Yes. So 3s are 3 5s are 15, 3 5s are 15, 16, 3 2 6 7, 65. 7 minus 5, 2, 0, 1, not 2. That's all. Okay. So here 255 into 3 and remainder is 102. So 255 into 3 plus 102. Now because the remainder is not 0, now my 255 will become my dividend 255, and now my divisor will be 102. I will have to divide this again. Now my divisor is 255 and my divisor is 102. Dividend is 255, 102. This I think 2 2s are 4, 0, 2 1s are 2. Yes, this will be fine. So here 2s are 204, 1, 5. 51 is my remainder now. 102 into 2 plus 51. Okay, into 2 plus 51. Now next time what will happen? 102 will become my dividend and 51 will become my divisor, and it's quite visible. 2 1s are 2, 2 5s are 10. This is multiplied by 2 plus 0. So here if you'll see, yes, here if you'll see, the remainder is 0 when the divisor is 51. Okay, so the remainder is 0 when divisor is 51. Therefore, HCF of 8, 6, 7 and 2, 5, 5. 8, 6, 7 and 2, 5, 5 is equal to 51. That's all. In this way, students, we have finished first question. Okay. Now going to the second question, which is of the second type that we have done. My dear students, if it's very important that before we proceed further, you have nicely done your lesson 2, 3, 4 that I have posted earlier. If you don't understand, or if you have not properly gone through lesson 2, 3 and 4, then you will find it very difficult or near to impossible to understand the next questions, especially 2, 4 and 5. If you have not properly gone through those lessons, then kindly you can even now stop the video, go over there, go through those videos first, understand those videos. It's very, very, very important and very, very, very necessary. And only then think about these questions, especially question number 2, 4 and 5. But if you have understood those videos nicely, then definitely you will understand these questions. So going to question number 2. Fine. Question number 2. What is question number 2? Show that any positive odd integer, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Now see here, my students, I have told you before, you have to apply your Euclid's algorithm over here, and according to Euclid's algorithm, the equation is what? A is equal to BQ plus C, right? A is equal to BQ plus C, where A is your dividend, B is your divisor, Q is your quotient, and sorry, not C, R. R is your remainder. And from this question, we have to fetch what your A is going to be. And it's clearly stated, show that any positive odd integer, positive odd integer, that means your A is odd integer. Fine, your A is odd integer and your B is going to be your 6. Fine, divisor is 6. So what I'll write over here, see here, let A be any positive odd integer. Fine, B is equal to 6. Then the possible remainders are, what are the possible remainders over here? You can write this also, dear students. This becomes very helpful for the examiner or the checker to understand. You are dividing this. Now this is your 6. So what are the possible remainders? You are dividing by 6. Your divisor is 6. So what are your possible remainders? They can be 0, they can be 1, 2, 3, 4 and 5. These are the possible remainders. So are what? 0, 1, 2, 3, 4, 5. Fine. Therefore, A is equal to, by Euclid's algorithm, you will get A is equal to BQ plus R, means A is equal to, in the first case it is going to be BQ plus R. B is your 6Q plus 0. First is 0, so that is okay. Or 6Q plus 1, or 6Q plus 2, or 6Q plus 3, or 6Q plus 4, or 6Q plus 5. Fine. These are the possible equations that you will get if you are going to divide A by any 6. You are going to divide any integer A by 6. So either you will get 6Q directly, there is no remainder, or you will get 6Q plus 1, 6Q plus 2, plus 6Q plus 3, 6Q plus 4, 6Q plus 5. But what you have to prove, it is going to be only 6Q plus 1, 6Q plus 3, 6Q plus 5. And why this is happening? Because you are actually positive A is what? Odd integer. Because this is odd integer, A cannot be 6Q. I have told you yesterday, I have told you before this in the basic lessons, that 6Q is an even number. 6Q plus 2 is a even number. 6Q plus 4 is a even number. So you will have to discard them. You can't consider them. So you will tell over here, but since A is a positive odd integer, A is equal to 6q plus 2, 6q plus 4 is not possible. So therefore we get A is equal to which all numbers? 6q plus 1 or 6q plus 3 or 6q plus 5. Hope you all are understanding this. It's going smooth and clean. As you go further, as you go higher level of questions, you will be sharper with this type of questions. Now we will go to the third question. This third question will give you a fair idea of the exact meaning of HCF. It will give the fair idea of that. See here, I'm not going to write the whole question, it's too big, but I think I will have to write otherwise. An army contingent of 616 members is to march behind an army band of 32 members. See, what are they trying to tell you? An army contingent of 616 members is to march behind an army band, is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? This is the important question. Important part of the question. Basically, what is the maximum number of columns in which they can march? In which they can march. See here, students, I feel that you must be knowing that exactly what is the question they're dealing with. See, let us go for smaller numbers first. Will not go to the numbers like 616 and 32 first to understand the meaning of the question. See, what are they trying to tell you is that they are talking about an army band. If you have seen the army parade on 26th January or 15th August on Rajpath and all, you will see that army band and army soldiers are there. They are marching in this fashion. If supposing these are the soldiers, and then there is a band in front of them. They are playing some or the other instrument, something like that. Of course, there can be two members over here also, and then one member over here, and then the parade is marching. But at present, they are asking you to deal only with this part of the parade. So let us consider, supposing I have got, I think you got the idea of what the parade is there, in what way the parade is, and what are they expecting you to do. They are expecting you to divide the number of soldiers who are going to parade and the number of musicians who are going to play an instrument in front of the parade, and they are going to march. It should not look like It should not look like this. This cannot happen. That there are two soldiers missing over here, two musicians missing over here. No, it should be a perfect complete square or a complete rectangle. Sorry. So this is what they are expecting you to do, and this you are not supposed to do. Okay, fine. Missing, 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 missing. No, it should be like this. Now let us take some smaller example. Supposing if there would have been 30 soldiers and there would have been 24 musicians. See, how can you divide them? How can you separate them? See, if I want to divide them in equal columns, so if I will have to divide them into equal columns, so I will divide this by number 2. If I divide this by number 2, this also is divisible by number 2. That means I am dividing them into 2 columns. I am dividing these soldiers in 2 columns, and at the same time I can divide these musicians also in the 2 columns. So they will look something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Fine. They will be marching like this, and then at the same time I will keep 24 musicians over there, and they also can be kept in the 2 columns, because this can be divisible by 2. That will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fine. This way the parade will march. How ugly it will look. Still, this is also a division you have done. But what are they asking you? What is the maximum number of columns in which they can march? They can definitely march in 2 columns. There is no harm in doing that. Though it may not be a good looking parade, but it is possible that you can divide them into 2 columns and then they will march. If I go to make more number of columns, I can select another number 3, because 3 will divide 30 and 3 will also divide 24. Fine. So I will make 3 columns. Similarly, I will make 3 columns and then they will march. I hope you are able to understand. You will try to make 3 columns. I'll like to see you visualize everything, so I like to go for drawing them. 3 tens are 30. So 3 columns, and then there will be 10 soldiers in 1 row. 3, 3, 6, 7, 8, 9, 3, 3, 6, 7, 8, 9, 10. That's all. 3, 3, 6, 7, 8, 9, 10. So these are the soldiers, and then there will be 8 rows. Exactly 8 rows. 3 8s are 24. So 1, 2, 3, 4, 5, 6, 7, 8. Like this they will march. Okay, fine. But then again they are asking me to make maximum number of columns. Can I make more number of columns? I can go for 4, but then 4, if I go for 4 columns, then 4 is not dividing 30, 4 is definitely dividing 24. I can go for 5. 5 is dividing 30, but it's not dividing 24. See, try to understand what I am finding, what I am trying to achieve. See, every time I am trying to achieve a factor, I am trying to find a number which is going to divide 30, which is going to divide 24. It has to be a factor, and not only a factor, it has to be a common factor. That factor is a number which will divide 30 and also 24. That's why I have to choose for common factors. And now going to the next word highest, I have to find that highest number, the largest number which can divide both. Hope you are understanding now. So 5, 6, yes, 6 can divide 30 to make 5 rows, and 6 can divide 4 to make 4 rows, right? 6 5s are 30, 6 4s are 24. Can I go higher than that? Probably not. For that, what should I do? I should find highest common factor of 30 and 24. Dear students, of course you can apply division lemma, and you will have to apply division lemma when you are solving it in your solution. But I will tell you always the faster method to counter check your answer, always go on dividing them simultaneously, dividing them, factorize them at a time. Of course there is a method that which we have done, finding HCF by basic arithmetic method, by finding the 5 factors, but this I am telling you personally, do it in the rough work, simultaneously factorize them. You can't waste your time to counter check your answer, finding the factor of 30, finding the factor of 24, and then taking the common factors and then taking the lowest power. That is a time consuming procedure. This is the faster procedure. Go on dividing this commonly, and you should divide when you are finding HCF. When you are finding HCF, you should divide them as long as you can divide them simultaneously. Both the numbers are getting divided, till then you should go on dividing them. So 2 15s are, 2 12s are. Fine. Now 2 is not divisible. 2 is not dividing 15, but definitely 3 can divide both. 3 5s are, 3 4s are. Now 5 is a prime number, definitely this is not divisible by any other number, and 5 will be divided by 5 only, and then 4 also is not divisible. So here the simultaneous division stops. So your HCF is going to be 2 3s are 6, that's all. Similarly, if I proceed further, 5 1s are, and then this comes 4, 2 2s are 4. Then what I get, this is an LCM. This is LCM. And if I stop where they are divisible simultaneously, there I will get HCF. So 6 will be the proper number of columns, maximum number of columns that can be, the parade can march simultaneously, will be 6 columns. And of course, because there are 6 columns, at that time there will be 5 rows of rows of soldiers and 4 rows of musicians. Fine. But this is, as I told you, this you don't have to actually go to this method. This is needed only for higher levels, higher level of numbers, larger numbers. For smaller numbers, you can still visualize like that only, that 3 is divisible by 3 is dividing 30 and as well as dividing 24. 6 is dividing 30 and as well as 24. And then the higher number 12, 2s are 24 and 12 is not dividing 30. Then again 20, then 18 and all. You will be able to understand that 6 is the largest number which is dividing both, is a common factor of them. So you will spread these parade in 6 columns and then you will be able to march it. But now you should have understood by now that the easiest way to find this for higher numbers is just find the HCF of the two numbers. Find the HCF, because why are you finding the HCF? Because you are basically trying to find that common factor of the two numbers. The common factor of the two numbers will tell you that they are equally divided like this, in proper fashion, uniformly they are divided. There will be no left outs like this. If I take any other number, 4 if I take, then definitely I will be able to make 30, it's not possible. 4 columns if I go to make, if you will see, you will leave some places blank over there. Try making this type of drawings. It's very nice to draw, I tell you my dear students, it's always nice. Drawing will clear your thoughts. It's time consuming, it takes time, but it clears all the thoughts. So Coming back to our question, now here 616 are the soldiers and 32 are the musicians. So now if I go to find the number common factor of 32 and 616, to find the common factor, the 2 I can make out, 2 is the one, 3 is not, because 6 plus 6 12 and plus 1 13, and then it will be 4. Yes, 4 will be the common factor. 4 can divide this and 4 can divide 32 also, and then it is becoming nuisance. It's not higher number. How do I trace 616? So the best way is find the HCF of 616 and 32, and that will be the number of columns. Easy as that. So I hope you have understood the explanation. I go to solve this. Here we'll tell the same thing again. Finding HCF of 616 and 32 by division lemma. And here I tell you, if this question comes in your exam, if you find this HCF by basic arithmetic method, even then it's okay. See, because this question is coming in exercise 1.1. In exercise 1.1 they have showed you only finding the HCF by Euclid's algorithm, so by division lemma. So definitely you will have to solve by find the HCF with the help of this only. But once your exercise 1.2 also is over, then in exercise 1.2 you will be solving HCF by basic arithmetic method. So you can use any method. So but at present we will go by Euclid's lemma. So what do we get over here is by division lemma. So 616 is going to be your dividend and your divisor is going to be 32. So if I go to divide this, what do I get? 616 divided by 32. This will be 264, though 32 ones are 32. 29. Fine. And then this 6 comes down. Then 8 to the 16, 8 3 the 24, 25, 9 to the 18, 9 to the 27, 28. Okay, 9 the 9 to the 18, 9 to the 27, 28. 8 is the remainder. Okay, fine. 8 is the remainder. 32 into, just a minute, this is moving. 32 into 19 plus the remainder is 8. Now in the next step what will happen? 32 will become by 32 will become my dividend and 8 will become my divisor, and 8 4s are 32 plus 0. So the remainder is 0 here, since the remainder is 0 when divisor is 8. Therefore HCF of 616 and 32 is 8. So therefore they can make 8 columns. Therefore what we will tell, that they will make 8 columns. Fine. What is the maximum number of columns in which they can march? Therefore they can make maximum 8 columns to march. That's all. So going further, if you'll consider this, see, actually this question, I'll tell you one thing more. See, this is there, you will go by this method, of course. बट देन काउंटर चेक करने का है तो 616 एंड what 32. See, if I go on dividing by prime factors, 2 3s are 6, this is the deadly one, 2 3s are 6, 0 is remaining, 0 1, so this will be 0 and then 8, 2 16s are 32, then again 2 1s are 2, 2 5s are 10, 2 4s are 8, 2 8s are 16, then again 2 7s are 14, 2 7s are 14, 2 4s are 8. Here 77 is not, you can't, simultaneous division is over. So your HCF is this, and these are the number of rows. These are the number of rows that the army soldiers will be marching, and these are the number of rows that the musicians will be marching in. So that's why I like this method. It gives you all the information. Fine, but we'll have to go by this method. Hope you all are understanding what's happening, my dear students. Now the next part of the question, next questions, that is question number 4 and question number 5, they are definitely not easy for you to grasp. It requires some amount of revision again and again and again and again. If you feel that you are tired, you can just pause the video over here, you can stop, you can take a break, you can have a nap, you can have some coffee, and you can join it again if you feel so. But I like to go with this, and this is question number 4 that I am continuing with. And what is this question about telling? Use Euclid's division lemma. Use Euclid's division lemma to show that the square of any positive integer, to show that the square, now see, you have come to square of any positive integer is either of form (3m), now here m has come, or 3m plus 1 for some integer. I don't know what this number is. It is some integer m. See, here don't get bothered about m. I told you before also, m is just a variable. Q is just a variable, x is just a variable. It can be anything over there. But even now you have to stick to that topic, that you have to convert them into a is equal to bq plus r, where your a is going to be what now? Use Euclid's division lemma to show that the square of, it is going to be a square of any positive integer. This is positive integer, neither odd nor even, nothing of that sort, only positive integer. This is just a positive integer. This a is going to be your positive integer. B is going to be what? 3. That's all. You will still keep it q. How the game of q and m is going to be, it's nothing of that sort. But of course you have to set your mind. You have to set your mind that how to convert them to a typical required frame. This is just the frame, nothing more than that. I'll show you how and what and how. So you will proceed in the same fashion. First of all, a is equal to bq plus r. So what I'm going to write over here, solution, let a be any positive integer. Fine. Let b be equal to 3. So now you can understand this, like if I am dividing a by 3, then the quotient will be anything, but the remainder is going to be 0, 1, 2. That's all. So here, therefore, for Euclid's algorithm, the possible remainders are 0, 1, 2. Therefore, A is going to be equal to 3Q or 3Q plus 1 or 3Q plus 2. Fine. You know up to here, you have done up to here, but now what is the next step they are wanting you to do is that they are asking you only not to deal with positive integer, square of positive integer. So A is going to be 3Q. One case, A is going to be 3Q plus 1. Another case, A is going to be 3Q plus 2. Another case. But what about A square? So we will have to take all the cases, my dear students. What will happen? Case 1. In case 1, what happens? A is equal to 3Q we have got. And then they want you to take the square. So taking square of both the sides, A is equal to 3Q. I take a square of this, and this also I will have to take square. Now what you have to do is A square. I can write this 9Q square. Okay, fine. I'll write this 9Q square. I'll open this. This square is applicable to 3. This square is applicable to Q also. So that's why it will be 9Q square. But now what I'm telling you is it is just a setting in a proper frame. This is what you have got. Your A square will be 9Q square, and they want you, your A square should be either 3M or 3M plus 1. Means you have to set it in this frame, 3M or 3M plus 1. When they want you to set it into 3M or 3M plus 1, what they want you to set it, it is a multiple of 3. Some multiple of 3, some multiple of 3 plus 1. Are you getting? Some multiple of 3 plus either some multiple of 3 only or some multiple of 3 plus 1. So I will require to make this also a multiple of 3. So A square will be equal to multiple of 3 means I will have to factorize this 3 into 3Q square. Are you getting? So now this is coming to my frame. A square, square of any positive integer is, square of any positive integer, A square is a square of any positive integer is 3M or 3M plus 1. Now what is this? 3M. 3M. My M is 3Q square. So I will tell here, therefore A square is equal to 3M, where M is equal to 3Q square. 3Q square. Don't bother about this. This M can be any value. What are they wanting you to understand? That it is going to be a multiple of 3. You're getting confused, my dear students? See, taste that maths. Taste that maths. See, try to understand the question. We'll go further. Otherwise, I'd like to complete this question, my dear students. Otherwise, again, we'll lose that thread. Case 2. I want to first continue with this thread. What I'm doing. I'm getting case 1. And because they are asking me to find the square, if they would have asked me to find the cube of any positive integer, I would have taken cube of both the sides. Okay? And that is what is going to happen in the next question. So, square, that's why I'm taking square of both the sides. And then afterwards, I want to make them, to set it into the form of multiple of 3. That's why I split this into some product of 3. So, when it goes to the second case, what is the second case? 3Q plus 1. A is equal to what? 3Q plus 1. So, I'll square of 3Q plus 1 the whole square. Now, what is the identity of this? A plus B the whole square is equal to A square plus 2AB plus B square. Some students say A square plus B square plus 2AB. I say A square plus 2AB plus B square. Whatever it is, it's all the same. So what will this be then? A square is equal to, I'll 3Q the whole square plus 2 into 3q into 1 plus 1 square. So a square is equal to 9q square plus 6q plus 1. Now what frame can you set this into? 3m or 3m plus 1? See, plus 1 is needed, plus 1 is over here. Now only thing is that this is your 3m. This should be your 3m. Okay? So to get this 3 over here, I will do what? This is my 3m. Plus 1 is already present. This is going to be set into this form. So I will do what? I will take common factor 3. See, actually common factor is what? 3q. But I have to manipulatively select only 3 because I want it into the factor as factor of 3. Multiple of 3. So 3 I will take out, and what will stay inside? 3q square, right? 3 3s are 9, q square comes over here, plus 3 2s are 6, and q also continues, plus 1. So what I get is a square is equal to 3. Now this is my m plus 1, where m is equal to what? 3q square plus 2q. 3q square plus 2q. Fine. So I've got this. Either it is 3m or it is 3m plus 1. Case 3. What is the case 3? 3q plus 2. Fine. So case 3 is 3q plus 2. So case 3, a is equal to 3q plus 2. Again, because they have asked me to find the square of both the positive integer, I will take square of both the sides because I want a square. A square. Again here, same thing. A plus b the whole square. Identity is what? A square plus 2ab plus b square. So what I get over here? 3q the whole square plus 2 into 3q into 2 plus 2 square. So a square is equal to 9q square. 2 2s are 4, 3s are 12q plus 4. Fine. Now what, my dear students? You have to put it into the frame of 3m or 3m plus 1. And what have you got? Plus 4. Don't worry. Just what? You want plus 1? So then just remove 1 out of this. So what you will get is equal to 9q square plus 12q plus 4 will be written in the form of 3 plus 1. Are you getting this 4? I am written in the form of 3 plus 1. So I have got my plus 1 over here now. So here will be my 3m. So I will take out 3 from here. Try to understand. This is my 3m. I will take out 3 common factor from here. 3 common factor from here. Now 3's are 9. So 3q square plus 3 4's are 12. 4q plus 3 1's are 3 plus 1. Fine. So what is my m? This is my m. So a square is equal to 3m plus 1, where m is equal to what? This whole bracket. 3q square plus 4q plus 1. That's all. Therefore, a square is equal to 3m or 3m plus 1 or 3m plus 1. That's all. From 1, 2, Therefore, from 1, 2 and 3, we get a square is equal to 3m or 3m plus 1. Fine. So here we finish with the fourth question. Fourth question. And then we come to the last question of the exercise, that is the fifth question. And what is the fifth question? Use Euclid's division lemma. So it is same, don't worry, you will be able to understand this faster. Euclid's division lemma. Use Euclid's division lemma to show that the cube of, now cube, to show that the cube of any positive integer, of any positive integer is of the form what? 9m plus 1, 9m plus 8. That reminds me, I had to explain you, give the taste of this question. I forgot that. Let me remember after this question if you'll understand. Okay, we'll taste them together. Solution. Now, you have understood this also. By now, you must have got the idea. Things must be moving nicely in your brain. Your Euclid's division algorithm is A is equal to BQ plus R. So in this case, any positive integer, A is equal to A, let A be any positive integer. And what is going to be a B? I guess you must be telling 9. And yes, it can be 9. No harm in taking 9. But then what will be the remainders? The remainders will be 0, 1, 2, 3, 4, 5, 6, 7, 8. That means you will be having how many cases? Not 8, 9 cases. 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 cases. And then you will have to solve 9 cases. That will be a very long procedure. So we can take, see what is the question, they want you to set that frame into 9m. You should bring that cubes should be in the frame of 9m, 9m plus 1 or 9m plus 8. So we will take the common factor 9. Simple. We will still take, let b be equal to 3. Because 3 is the multiple of 9. Simple. Sorry, 3 is the factor of 9. So, by Euclid's algorithm, the possible remainders. What are the possible remainders? A is going to be divided by 3, some quotient you will have, and then R is going to be either 0 or 1 or 2. That's all. 3 cases. So, R 0, 1, 2. Therefore, A is going to be equal to 3q, only 3q plus 0 is 3q, or 3q plus 1, or 3q plus 2. Fine. These are the cases. And now same procedure. Case 1. A is equal to 3q. And because they are asking you to find the cube of any positive integer, so I will take cube of both the sides. Simple. Fine. And then A cube is equal to 3 3s are 9, 3s are 27, 27q cube. Now to set it into the frame of 9m. So of course you can say it is going to set into the frame of 9m. So I will take split this 27 as 9 into 3. 27, 9 into 3, q cube. So therefore a cube is equal to 9m. 9m, where m is equal to 3q cube. Got it? So this is my case 1 and solution 1. Okay, fine. I hope you all are getting what is happening. And now going to the next one, case 2. In case 2, what I get? A is equal to 3q plus 1. 3q plus 1, 3q plus 2. So here I will have to take the cubes of both the sides. Taking the cubes of both the sides. So a cube is equal to 3q plus 1 the whole cube. Now you require the identity of a plus b the whole cube is going to be equal to a cube plus 3a square b plus 3ab square plus b cube. There are two identities over here. You can take any identity, don't worry. Both the identities are same. The other one is what? Actually a cube plus b cube plus, actually speaking, a cube plus b cube is taken over here. They are taking a common factor of this, 3ab bracket a plus b. You can take any, don't worry. Even if you take this, you will have to open the bracket and you will reach over here only. Fine. So this is what? So this is going to happen. So a cube is equal to a cube. That means 3q cube, right? A cube, 3q cube plus 3 is coming from outside. A square means 3q square into b. B is my 1. Plus 3 again coming from outside into a. A is 3q into b. B is my 1. Plus b cube is 1 cube. So what I get is a cube is equal to 3 3s are 9, 3s are 27 q cube plus 3 3s are 9, 3s are 27 q square plus 3 3s are 9 q plus 1. So you can see very easily that it is going to fit into plus 1 wala format. Fine. Plus 1 format of plus, no sorry, it's behind, 9m plus 1. Fine. So plus 1 is over here. So from here I will get the common factor 9 I have to take. Fine. So common factor 9. So it will become a cube is equal to, common factor is 9. So what stays? 9. 3s are 27, q cube follows. 9. 3s are 27, q square follows. 9. 1s are 9, q plus 1. So now here a cube is equal to 9m plus 1, where my m is this bracket, where m is equal to this whole bracket, 3q cube plus 3q square plus q. So this is my a cube. Second case. Now case third. A is going to be equal to 3q plus 2. Same thing I will do, my dear students. A cube is equal to 3q plus 2 the whole cube. Again the same thing. A cube plus 3a square b. So a cube is equal to a cube. This is my a. 3q cube plus 3 comes from outside. 3 into a square into b. 3 into a square. A is 3q. 3q square into b is my 2 plus next case 3 into a into b square. 3 into a is my 3q into b square is 2 square plus 2 cube. So what I get over here, a cube is equal to 3 3s are 9 3s are 27 q cube. This will be again 3 3s are 9 3s are 27 into 2, 54 q square plus 2 2s are 4, 3 3 are 9 4s are 36 q plus 8. Simple. You don't even have to split that 8. You require plus 8, so plus 8 has come on its own. So this is plus 8. Now here is your 9m. So a cube is equal to, I take out 9 as a common factor, 9 3s are 27 q cube plus 9 6 are 54 q square follows, 9 4 are 36 q follows plus 8. So this is my m. A cube is equal to 9m plus 8, where m is equal to 3q cube plus 6q square plus 4q. That's all. This is my third case from 1, 2 and 3. We get a cube is equal to either 9m or 9m plus 1 or 9m plus 8. That's over. Yes, I remember I have to give you the taste of this question. See, what do they mean when they say these all things? You can try to fetch out. See, I'll show you one and the other one you will take. I think I'll go really for the difficult one. I'll try to go for this one. That cube of any positive integer, either it is 9m, 9m plus 1, 9m plus 8. So if I take any positive integer, what are the positive integers that I have got is, supposing 3. So if I take the cube of 3, see, cube of 3, 27, and then I divide this by 9. Fine. What I get? 0 remainder. This is my m. Hai is equal to 9m. Right? Dividend is 27. Divisor is 9 into 3 plus 0. This is my m. Otherwise, what will be the remainder they are telling? Either the remainder will be 0 or the remainder will be 1 or the remainder will be, no. Either the remainder will be 0 or the remainder will be 1 or the remainder will be 8. That's what they are telling. If I find the cube of any number and then divide that number by 9, the meaning of this question, if I find the cube of any integer and then divide that cube by 9, then the remainder will either be 0 or it will be 1 or it will be 8. So here if you will say in this case 27, the remainder is 0. I go for the next cube. 4 4 the 16, then 4 cube is 64. If I divide this 64 by 9, what do I get? 9 7s are 63, 1 is the remainder. One time the remainder is 0, now the remainder is 1. Now I go for the next 5 cube. 5 cube is 125 and I divide this by 9. If I divide this by 9, it's a 70, no, 9 ones are 9, 35, and then I go 9 3s are 27, 28, 29, 30, 31, 32, 33, 34, 35, 8 is the remainder. That's what they are trying to explain you. You take any damn number, 50 cube, then divide that 50 cube by 9, the remainder will be either 0 or it will be 1 or it will be 8. Either it will be 1 or it will be 8. That's what they are telling over here also in the previous question. That if I take a square of any number and then divide that square by 3, then either the remainder will be 0 or 1. That's all. Try doing this. Try any number, take the square of that number and divide that number by 3 and check what you are getting. That's the meaning of this question. My dear students, understand this meaning, solve the questions, keep on solving these questions. The video has gone too long, I'm telling, but then we have finished exercise 1.1. Congratulations. Welcome to your maths, and then solve this exercise on your own, especially question number 3, 4, 5. Solve them, understand them. Question number 3, 4, 5, they can come in any form. They can come in any form. One example is there, example number 4 in your textbook, where a sweet seller is using sweets. 420 kaju burfis are there, 130 badam burfis are there. Same thing is happening. They want to stack these 420 kaju burfis and 130 badam burfis. They want to stack them together. You must have seen sometimes when you take that sweets in a sweet box, and then you take the sweet in the sweet box, you take some burfis, you take some pedas, other chocolate pedas or white pedas, mava pedas. Then the shopkeeper keeps them, arranges them on the top in a box. Sometimes chocolate pedas down, and on top they will arrange the white mava pedas, and then they have to be uniformly kept. So what you will do over here, again you will find the HCF of 420 and 130. Find the HCF of 420 and 130. That will tell you exact number of columns that you are going to frame, so that all the burfis and all the badam burfis and all the kaju burfis sit over there properly. See this, it's very nice. So congratulations that you have finished with your first exercise 1.1. Tomorrow you all solve exercise 1.2. Start solving this exercise 1.2, and I'll solve that exercise 1.2 for you all people. So my dear students, take care, stay at home, don't go out, things are not good. Stay calm, stay focused, study nicely my dear students, study nicely. I love you all. Thank you.